All right, so I want to talk just about one other strategy you could use to solve something like this. It's not always going to lead to perfect values. Sometimes it'll lead to imprecise decimal approximations, but it's a pretty cool tool, especially if you're trying to, I don't know, maybe practice for the SAT, or just be able to solve a multiple choice type of problem, or just find a way to check an answer even. So what I'm going to do, and you can see the problem is going to disappear, I'm sorry about that, but what we're trying to solve is when cotangent equals 1. And so what I can do is I can go ahead and make a graph of cotangent, and what I'm really looking for is when is the value of this going to equal 1? When is the value of this function going to equal 1? Now remember, what we have down here, we have our, our x values, which are really like our angles. And then on the y-axis, we have our cotangent values. So this is really what our cotangent values are. So when we say we want cotangent to be equal 1, we're really saying that we want our output to be 1. We want the output of the cotangent function to be 1. We want our y value to be 1. And so what I'm looking for really then are these spots right there, 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 anywhere where y equals 1. And I can see them right now, but it'd be great to get them to show up kind of naturally, I guess. So when you look, all the spots I'm looking for where the y value equals 1, I'm really looking for any spot on this line. And so what I can do is instead of drawing them by hand, I can go ahead and sketch that line. You see I have y equals 1 here. And so what I'm going to do is I'm going to go ahead and sketch that line. And then if we look in decimals, look at that. 5 pi over 4. Pi over 4. 3 pi, or negative 3 pi over 4. And negative 7 pi over 4. And so those are my solutions. X equals negative 7 pi over 4. Blah, blah, blah. Now, we could find the others. The one over here and the one over here. But when you look, that's going to be outside of 2 rotations. Or sorry, 1 rotation is going to be outside of 2 pi. And this one back here is also going to be outside of negative 2 pi. And so that's why I didn't choose to look at those. Because if you think back to the problem, we were trying to find all the solutions on the interval negative 2 pi to 2 pi. And so I really only wanted to look between, right in that region of the x values. And so I didn't really need to find those other ones. So anyway, this is a great tool to use. Hope that helps. Have a good one.